Bro, I think I caught something worse than a week 10 burnout.
Relax, tell me your symptoms.
It could be anywhere from a mild flu to impending doom.
Yeah, that tracks. Breaking news. Search volume for flu symptoms UCSD. Why is everyone coughing in Geisel and does SHS take walk-ins? Please help. Is up 300% in the last 48 hours.
That was me.
And here we have the official CDC influenza-like illness report from last week.
So helpful. Thank you. Truly cutting edge.
Patience is a public health virtue.
Oh my God!
Okay, we have two types of data. Google Trends, which is chaotic but instant. And we have CDC reports, which are accurate but delayed. We aligned weekly search patterns with last week's CDC ILI signals, trained a machine learning model, and guess what? It predicted a flu spike this week, before it happened. So all those people Googling, why do I feel like I'm dying, were actually useful?
This is the future of public health surveillance.
Does your model predict whether I'm dying?
Oh yeah. No, you're fine. You just need some sleep.
Alright, now that we've diagnosed our friend with being dramatic, let's talk about the actual project. What we saw in the skit is exactly the problem we're trying to solve. When people feel sick, the first thing they do is Google their symptoms. When the CDC wants to tell us how sick everyone is, they do it next week. So this was a research question which basically asked, can Google panic searching help us predict flu activity faster than the CDC does? Now, fun fact, Google actually tried this years ago with Google Flu Trends and it completely exploded. It missed whole flu seasons, it overpredicted, and at one point it basically thought everyone in America had influenza. But more recent research shows that if you don't use fancy names like the disease names and instead look at symptom searches like fever and body aches, you can actually get a cleaner signal. And only if you combine it with CDC instead of pretending Google alone is a doctor. So, our hypothesis was if a bunch of Californians suddenly Google fever at 2 a.m., that should tell us something about flu activity, and ideally before the CDC catches up. So, adding Google Trends to past CDC data should improve our forecasts, at least a little. To test that, we used two datasets, one chaotic, one responsible. The first dataset was CDC FluView data, which is weekly influenza-like illness percentages from 2017 to 2024. This is like the grown-up in the room, accurate, polished, and late to every meeting. Second, Google Trends, weekly California search volumes for flu symptoms. This is the unhinged cousin who texts you at 3 a.m. saying, why do I feel like I'm dying? But it updates instantly, which is exactly what we need. We merged the two week by week, basically forcing the responsible CDC data and the chaotic search data to sit next to each other and cooperate. We aligned everything, added the week's start dates, built a composite symptom index, and created 1 to 2 week lags for both CDC and search features. The final dataset has 355 weeks and 34 variables, enough for us to build models, test our hypothesis, and finally answer the question, does Google panic actually help predict the flu?
First up, the EDA. Look at this beautiful seasonal pattern here. We can see that the flu spikes up every winter like clockwork. Shocking, I know, who could have predicted that respiratory viruses thrive when everyone's indoors coughing on each other? Looking at the lead lag analysis, this is where it really gets interesting. We thought that the Google searches would predict the flu, like people would search fever a week before going to the doctor. We were completely wrong. They search while they're sick. The lag is 0. And it turns out that people don't really plan their flu season in advance. Who knew? And then COVID-19 happened, and it completely nuked our data. People were searching body aches like crazy, but flu rates were at 0 because people were locked inside doing nothing. Nevertheless, we acknowledge that this might degrade the performance of our model, but we still decided to retain the COVID period in our training data to make it robust. Now, moving on to our model, we trained an ARIMA model based on 312 weeks of training data from 2017 to 2023, and we used 2025 as our test data to test our model. We used the features on the baseline, the original ILI data from the CDC, and we added up our search data onto that from Google Search Trends. Now, after training our model and optimizing our model based on the input data, we calculated two different numbers. One is the performance of the model with the Google Search Trends data, and one is the performance without it. We found that the performance improvement was merely 3%, and running the p-value test yielded a p-value of 0.84, which means that at an alpha of 0.05, this is not significant. That is, the performance improvement of 3% is not significant enough for us to confirm that adding Google Search Trends does make our model better. But wait, there's more. When we split our data by season, everything changed. During winter, when the flu actually matters, Google Search Trends actually improved our accuracy by 19%. Hospitals would literally pay for that. But in the summer, when flu is basically non-existent and everyone's Googling fever because they got sunburn at the beach, it made it 64% worse. We made the predictions actively bad. The lesson, Google Search Trends is really helpful during the crisis, during when everything's packed and everyone's getting sick. But it's absolutely useless, actually being counterintuitive when it's light and no one's getting sick in the summer. So what's the takeaway? Deploy the Google Trends only from November to March. Use it when the hospitals are slammed and accuracy matters. And then turn it off in the summer when flu's at 1%, and you can predict that with a calendar. I think this explains why Google Flu Trends failed back in 2015. They ran it year-round, accumulated 8 months of garbage predictions, and it drowned out the accuracy generated by the 4 months where it actually worked. And that's how we accidentally discovered that context matters more than fancy models. Thank you.